in this video. Section 5.3, the two-point form of a line. Now, to begin, we're going to think about 2 points. I want to take the 2 points, 1, 2, and the point 3, 6. And what we're going to do with these points is think about how the coordinates change from this first point over here to this second point over here. Now, x goes from 1 to 3. And then y goes from 2 to 6. This change in x, 1 to 3, is a difference of 3 minus 1, 2 units. Whereas y goes from 2 to 6, so that's a change of 6 minus 2, 4 units. Now, in a line, this change is constant. It's always changing by the same amount. So, we want to think about the ratio of this change. We're going to think about the change in y over the change in x. So that's 6 minus 2 divided by 3 minus 1, which is 4 divided by 2. And we're actually going to go ahead and simplify this to be just 2. Now let's think about what we did here. We had that first x point, and we want to think about how we would describe this in general. We had the first point here, and it's got an x, and it's got a y. We've got our second point here, and it's got an x, and it's got a y. So to tell them apart, we're going to use a little subscript here. Subscript 1, subscript 1. This will get a subscript 2, a subscript 2. So then we could write out that we had, let's see here, it was change in y over change in x, so that's where we ended up, y2 minus where we started, y1. We'll fix that. Minus where we started, y1. And then for the x's, it's where we ended up, x2, minus where we started, x1. And we call this relationship the slope of this line. And we use m to represent slope. Why m? Because m. Truthfully. So now if we think about a line, one of the ways that we could just describe a line is all the points whose slope with a common point is the same. So let's bring up some axes, and we'll find where 3, 6 is. And that was, let's see here, 1, 2, 3, 1, 2, 3, 4, 5, 6. 3, 6. Then we'll find 1, 2. We'll just graph this guy. 1, 2. And then we'll go ahead and we'll pass a line through these 2 points here. Perfect. We'll go back through. Now let's think, what if we had a third point on this line? That's what we want to think about, is the other points on this line. What if we had a third point? Could it be like off here somewhere? No, that's not on the line. And if we think about how it passes through that first point, that red point, that slope relationship, how much x is changing versus how much y is changing. I go over 1 unit here. 1 unit in x and I shoot up in y, I go over 1 unit in x on that line, I'm just only going up about 1.5 for y. So that rate of change isn't the same. And that's the slope. So let's think about that. Let's take two general points. And these 2 points we'll describe using the indexes. We'll have x1, y1, and then x2, y2. And the slope between these 2 points will be y2 minus y1 divided by x2 minus x1. And again, this was the slope. Now let's get a third point involved. And we're just going to use x and y without any index to describe this third point. The situation we're thinking about is we've got 2 specific points, and we're thinking about just what qualities an additional point or any of the additional points that lie on this line might have. And use slope to describe that. We want to look at the slope between the first point and this point. We want to look at that slope. And we're going to put that right here. So that's where we end up. Y minus where we started. Y1 divided by the x's. Okay, and then this right here, this proportion of the slopes is enough to describe the property that any point on this line better have. But I don't like it this way. I want something where I've got y on one side and then x on the other side. I want to take this x variable, move it over to the other side. How are we going to do that? Well, we're going to multiply both sides of this equation by this denominator. So we'll have x minus x1 times the left-hand side. And then we're going to have that equal to, so here y2 minus y1 divided by x2 minus x1. And look over here. This difference, they're the same. They're going to cancel out. We'll be left with y minus y1 is equal to y2 minus y1 divided by x2 minus x1 times the quantity x minus x1. As always, these parentheses are very, very important. It's an order of operations thing. If we don't have these parentheses here, we're talking about something different. We need those parentheses. And this right here is in fact the 2-point form of a line. It's theorem 5.3.3 in your textbook. And we can use it to find the equations of lines if we're given 2 points. So let's suppose we have the points 2, -5, and the point 8, 1, and we're interested in the line that passes through both of these points. We want to find that line. Well, we're just going to go ahead and take and say this is point 1, and we're going to call our other point point 2, and I'm going to take and plug in these values into the appropriate places, and I'm going to take and plug these values into the appropriate places. So to start, we would have, let's see here, y minus y1. The first y coordinate is a -5, and that's going to be equal to, let's see here, y2, that is 1 minus y1 again, so minus negative 5. We're going to divide that by x2, which is 8, minus x1, that's 2. And then we're going to multiply by x minus x1. And x1 was 2. It always pays to check when you're doing this. One note here is this minus minus, we can write those as addition. So if we wanted to, we could rewrite this as y plus 5 is equal to 1 plus 5 divided by 8 minus 2 times the quantity x minus 2. And there we go. That's the 2-point form of a line. Now, could we in fact simplify this? Of course we could. But if we're doing that, we're talking about a different form of a line. That's the next section. See you then. Thanks.